Good morning, my YouTube viewers. In this video, we're going to be doing some more experimental random design, or experimental design, really. And so in this experimental design, you have to follow 6 steps in order to do it. So number 1, we're going to define the research objective. Number 2, you're going to define the research methodology. Number 3, you're going to conduct a literature review. Number 4, you're going to develop a research design. Number 5, you're going to collect and analyze data. And number 6, you're going to present empirical findings. So what we're going to do now is experimental randomized block design. And in order to conduct experimental randomized block design, we've got a practice question, which again is to do with crop yields. So you've got a block of 1 to 4, because this is going to be block design. And then you have a treatment of A, B, C. So 4 blocks, and let's see what we've got here. We've got 4 blocks and 3 treatments, and then each block is going to have a yield, a crop yield. And so in order to do that, what we need to do is we need to create a pivot table. And I don't know if you know how to create a pivot table. I think I may have showed you how to do it in an earlier video, but you go to Insert, and then you you section off the data that you want. You go to Insert, and then you go Pivot Table, and that is how you create your pivot table. But we're not going to create a pivot table because we've already created one for this example. So we're going to have row labels and column labels. So the row labels are going to be A, B, C, and the column labels are going to be 1, 2, 3, 4, because you have 4 blocks. And then you have a grand total for 1, 2, 3, 4, as well as grand total for A, B, C. But what we're going to do is we're going to do another ANOVA, but this is going to be 2-factor without replication. So we come over here to our data, and then our data analysis, and then 2-factor without replication. We're going to click OK, and we're going to fill it out. So we're going to say our input range is going to be F3 to I5. And then we're not going to have any labels, and we're going to have an alpha of 0.05, and your output range is going to be E9. But we're not going to do that. We're not going to do that. And the reason why we're not going to do that is because we've already done it for this example. I was just showing you how to do it in case you want to do it yourself. So we're going to have ANOVA, 2-factor without replication. So you have a summary, and then you have a count, and then you have a sum, and then you have an average, and then you have a variance. And then so your F statistic tests the difference, and your p-value tests the probability. So you've got your rows and your columns and your errors, and you got your sum of squares, your degree of freedom, your MF, you've got your F statistic, and you got your p-value. So your p-value is going to be on the rows. And then, because that's going to be A, B, C. And then it's also going to be on your columns. And then, so let's look at the chart that we have made. So I think that it's going to say there's no significant difference. I believe that's going to say there's no significant difference. But you've got your rows, that's A, B, C, and then you've got your columns being 1, 2, 3, 4. And so you've got your first p-value on your rows is 0.04. So that's going to tell you that there is a significant difference. And then on the columns, it's 0.88. So that's going to tell you that there's no significant difference. So on the rows, you have a significant difference, and on the columns, you have no significant difference. So that's going to be a little bit harder to ascertain. But if we come over here, we've got our rows. The number 1 is 2.9, 2.8, 2.7, 2.6. And I think that there's no significant difference between the rows, just looking at it. But it says the rows, there is a significant difference, and the columns, there isn't a significant difference. So I just wonder if it got it a little bit backwards, because I would say that there's a significant difference between the columns, but no significant difference between the rows. But that's what it gives you. And then it gives you a chart as well. And I'm not going to go ahead and interpret the p-value, because we have two p-values. One p-value being 0.004, which means you're going to reject the null hypothesis, and then another p-value being 0.88, which means you're going to accept the null hypothesis. But you can see the chart that we've made up, and so I would say that the rows, there is a significant difference, and it says on the columns there's no significant difference. So that's it for the experimental randomized block design. And the next video is going to be another experimental design, and I hope you decide to watch it.